Hey guys, welcome to your first video lesson. Today we're going to talk about parabolas. We've done parabolas in the past, although the ones that we've talked about in the past have all been functions. So today we're going to introduce parabolas that are not functions. So basically they're going to fail the vertical line test, which means that they're going to open to the left or to the right. You should have already looked over your introduction to conics that goes through. There's a little flow chart for you to look at on how to identify different equations of different conics. So make sure you give that a quick look as we go through this unit. So there's some things that you need to be able to do in order to take your test in your practice quiz at the end of this unit. You have to be able to identify the equation of a parabola, and I can give it to you in any form, whether it be general or standard. You have to be able to write the equation of a parabola in standard form, and we'll talk about that today. And I'll be able to give you specific pieces of information. The other thing, two things that you need to be able to do is to convert from general to standard form using completing the square, and you also have to be able to graph a parabola, so that should be a given. If you want to print the notes out, just like all the other units, I have the Word document and the PDF there for your use. So let's start out by looking at the definition of a parabola here. There's two forms that you're used to seeing. The first one, f of x, being our vertex form, and then the y equals being your quadratic form. Again, we just discussed how we always talked about parabolas that were functions, and now we're going to introduce parabolas that are not functions. So just take a minute to pause the video and read the definition of a parabola there, and then when you're done, you can play the video and we'll talk about the parts that we're going to be looking at. Okay, so the different parts of your parabola, we still have the vertex, okay, that we've talked about before. You have your focus point, which is always inside the parabola. So no matter which direction your parabola opens, it will always, your focus point will always be inside the vertex. Notice there's a distance of p from your vertex to your focus and from your vertex to your directrix. Your directrix is either a horizontal or a vertical line. Make sure you make note of the equations for horizontal and vertical lines. And then we also have our axis of symmetry there, which you notice now is horizontal versus vertical, which we've been dealing with so far. These next two tables are basically just for your reference. We're going to look at some new equations that we've never dealt with before, such as y squared equals 4px and x squared equals 4py. These are different equations for your parabola. Notice if it's a y squared, then it opens to the left or to the right. And if it's an x squared, it opens up and down, which is the ones that you're used to. The ones that we're going to work with, we're going to look at when your vertex is at the origin, and we're also going to look at when your vertex is not at the origin. The coefficient of your x or your y has a value of 4 times p. So that p value tells you whether it's going to open left or right or up and down. Notice the only difference when it doesn't have a vertex at the origin is it turns to y minus k or an x minus h. And then depending on which way it's going to open is whether you're going to start with your y squared or your x squared. Another part of the parabola that we're going to talk about is called the latus rectum. That's going to help you as a graphing aid to determine how wide or how narrow your parabola is going to be no matter which direction it opens. So the latus rectum is a line segment. It is endpoints are on the parabola and it is collinear with your focus point. All right, so now we're going to look at finding the focus and the directrix of a parabola whose equation is y squared equals 8x. So the fact that we are starting with a y squared tells me that this is going to open to the left or the right. So this is y squared equals 4px. Now because there is no x minus h or y minus k values, I know that this equation tells me that my vertex is at the origin. Okay, so we have a vertex at the origin. Now we need to decide whether it's going to open to the left or to the right. So that's all going to depend on our our p value. So for p is equal to 8 being the coefficient of x, if I solve for p, I get a value of 2. Now, 2 is greater than 0, so since p is greater than 0, it's going to open to the right. Recall that that p-value is the distance between your vertex and your focus and your vertex and your directrix. So we're 2 units away from our focus, which means it's going 2 to the right. So this is now our focus point. So we know that our focus is at 2, 0. Now our directrix is going to go in the other direction. So that's going to go -2. So our directrix we have here, this is a vertical line. So remember your directrix is a x equals, in this case, -2. Now I'm going to go ahead and draw this parabola, and I need to know how wide my parabola is going to be. So I'm going to look for the length of the latus rectum. The latus rectum has a value of 4 times the absolute value of p. And as you do more of these examples, you'll notice that 4p, 4 times the absolute value of p, it's very easy to tell what it is. So in this case, it's just 8. Now, the whole distance is 8. That means that it is 4 units from the focus in each direction, up and down. So there's our latus rectum. So we know that our parabola is this wide. Okay, we found our focus, we found our directrix, and we happen to graph our parabola. Notice in this next example, it says determine the focus, the directrix, the length of the latus rectum of the parabola x squared equals -12y. So the fact that it is an x squared tells us that it is going to open up or down. So we need to determine whether it's going to open up or whether it's going to open down. So we know that 4p equals -12. So we have a p-value of -3. What that tells us is that this parabola is going to open down. Again, because we don't have an x minus h or a y minus k in our formula, our vertex is going to be at 0, 0. Our p-value is 3, so we have 1, 2, 3. So it's opening down. So the point that I just plotted here is my focus point. So focus point being at 0, -3. And then our directrix, this time, because it's opening down, is going to be a horizontal line. So your directrix at this point is y equals 3. Okay, now we also need to find the length of our latus rectum. Here's where that absolute value comes into play. So really, the length of our latus rectum is 12. So from our focus point, we're going to go over to the right 6 and over to the left 6. Causing our parabola to open down, be fairly wide. Okay, so we found our focus is at 0, -3. Our directrix is y equals 3. The length of our latus rectum was 12. Our parabola opened down, and we're done with that one. In this next example, it says graph the parabola given by the equation x squared minus 2x minus 8y minus 7 equals 0. This is what we call general form. So again, that was talked about in the intro to conics section at the beginning of your unit that is in your online notebook. So here we're going to have to complete the square with just your x's. So we're going to group those x's together. So to complete the square, I would have to add 1. Now I'm going to take my 8y and my 7. I'm going to move that over to the other side of my equation. So I have 8y plus 7, and then that plus 1 is going to get added over to the other side as well. You're going to go ahead and factor to complete the square there. So this becomes 8y plus 8. So this is going to become the quantity x minus 1 squared. I'm going to factor out an 8, leaving me with y plus 1. This is now your standard form of your parabola. Okay, now our vertex is no longer at the origin. Our vertex is now located at 1, -1. So our vertex is here. So notice we've changed where our vertex is. Now, the 8 in front of the y plus 1 is representing our 4p value. So we have a p-value of 2. Now, this one is going, since our p-value is positive, it starts with an x squared. So this is going to be opening up. So our focus is going to be at 1, 1. And our directrix is going to be down 2. It's going to be a horizontal line. So that's going to be at y equals negative 3. And the other thing we need to know is how wide our parabola needs to be. So finding our length of our latus rectum is 8. So from our focus, we're going to go to the left and right 4. And there's our parabola graphed. Okay, notice we moved from general form to standard form, identified the vertex, the focus, the directrix, and the length of our latus rectum to make sure that our parabola was more accurate. All right, for our last example, we're going to find the equation of the parabola whose vertex is located at 2, negative 3. So remember, your vertex gives you an h and a k value. And the focus is located at 0, negative 3. So one of the key things to your conic section is to graph. Even if this just says find the equation, a lot of times it's easier if you graph information that you know. It'll help you identify which direction your graphs may be opening, which way they are elongating when we get into ellipses. So in this case, my vertex is located at 2, negative 3, and my focus is at 0, negative 3. So remember, the focus is always inside your parabola, so that means that given the information we have, we know that this is going to open to the left. So if it's opening to the left, I need to start with a y squared. So I need a y minus k squared equals 4p times x minus h. So I can go ahead and substitute in the information I know, and I know that my p-value, the distance between my vertex and my focus, is 2. So I know that p is equal to 2. I have my vertex, which is my h and my k. So I'm going to go with y plus 3 squared equals 8 times x minus 2. And there's the equation. So I didn't have to graph a whole lot. It just reinforced the fact that I knew that it opened to the left. So when they're asking the equation, sometimes it's just beneficial to graph what you have, but it's not absolutely necessary. Now, if you wanted to go from standard form to general form, what you would do is distribute the 8, multiply out the y plus 3, and set everything equal to 0, and then you would be able to have general form. All right. You can now go ahead and complete the questions on Math Excel. You could review the video if you needed to, but the video will be there for the whole unit for you to go back and review when necessary. Hope you guys have a great day.